no 0.2 only nitrogen. Now the results of the helium isotopic ratio. This is 0.35 in Jotun and 0.4 and anything 8 or 7 in Troll. Okay, the argon results are a little bit higher than air, and this is not so pure mantle signature. But I wonder, what is the reason? We have quaternary volcanoes, and so, okay. If we plot these, this is a result from Eifel area in Central Europe. Eifel is located here, probably. And you see here in this area, near to Koblenz. Koblenz is a town here. And this is the river of Rhine. Here is one of the most important CO2 degassing area of the Eifel. And the center is the Lacher See area, okay? The volcano, the age of the volcano is 13,000 years. And we learned that in these circles there is dominated magmatic degassing, and here is a mixing, and here is crustal degassing. Okay, these are only 60 kilometers far. Yeah, so the magmatic input came probably 40 kilometers in the periphery. We see also in Köln some magmatic trend, and these you could also see if you compare it with Jotun and Troll. Jotun and Troll are in the intersection of magmatic and crustal degassing. Okay. The same is for Slovenia and Austria area. We saw it also. We detected in magmatic parts there. We detected in crustal parts there. The crustal part is also some tens of kilometers far from these, and mixed crust magma is, if we plot Troll and Jotun, is in between also there. The same, and this is quite interesting, because this is a new publication from last year. French colleagues mapped areas in a profile, north-south profile from Massif Central. We hold in our result the same helium isotopic ratio as we degas xenolites. If you degas xenolites, and if you collect gas at surface, this is the Morphette of Escarot near to a very young Pavang Mar, which is only 7,000 years old. Yeah, okay. This is the center of the magmatic degassing in the Massif Central, and the mix of magma and crustal degassing related to the helium isotopic ratio, we found, or they found, 180 kilometers north. Okay, you see it here. Magmatic degassing, this is crustal dominated degassing north in direction of Paris Basin, and if we compare it, we see the same here. Okay. Here we see also the trend related, once more related to the helium content. The helium content is very high in the Troll and Jotun gases, and this speaks for high content of crustal gas. Okay, now I come to the carbon isotopic ratio of CO2. And on the magma-dominated gases, here see example Eifel and example from Western Bohemia. The numbers are -3 promille or -2 promille. This is the magmatic sourced information from CO2, carbon isotopic ratio from CO2. We see in Jotun and Troll these numbers which are different, but not purely crust. Okay, so also in these we could see the same trend as in the helium or helium-neon isotopic ratios. Here we are in the middle part, and we are different from crustal degassing and different from magmatic degassing. Okay, now I come to methane. We could also make test research. It's a pity that Jotun has no methane as we made a research. And what these data tell us. And this is exciting result from monitoring which we made in Western Bohemia. You see here one monitored spring, Wettin-Quelle in Bad Brambach in Saxony, Germany, in between March 2000 up to October 2003. These are the numbers of the concentration. And this was an earthquake, a local earthquake here. And the concentration some 30 days after the earthquake increased dramatically. And we found in the carbon isotopic ratio of methane that there's an anomaly or a change in the numbers of the carbon isotopes. And what is very interesting, this is microbiological produced. This anomaly we saw, this is microbiologically produced. So, you could ask me after the lecture why also, but for our expedition, it was interesting that one number is a little bit related to microbiological trend, and one is at the thermogenic methane. So I don't know which trend is in these gases has. Probably they are a little bit microbiological changed. So, but what is important, what we could learn? The thermal springs give us information a little bit from magma, a lot of from crust, and probably also from microbiological activity. What further was for me very interesting is what is the detail of the mantle crust relationship, which geodynamic processes are behind. And now it's a speculation. I think that we have to look to the ocean. The distance between northwestern Spitsbergen and the mid-Atlantic ridge is only 200 kilometers. And if you compare it with the Massif Central news results, 180 kilometers, it's not so far. So for me, it's possible that the magmatic origin could come or the information could come via ocean processes. And so we have to look to the Knipovich Ridge or the mid-Atlantic ridges more, and not separate between oceanic geoscientists and terrestrial geoscientists. We have to co-work more. Yeah, okay. And the next interesting point is trigger mechanism. We learned a lot from earthquake processes, and earthquakes stimulate volatile transport a lot of. And so open question for me is how